Today's lesson is looking at comparing fractions. We particularly need to review a couple of symbols. We need to review these symbols. What is this one?
Greater than.
Yeah, less than. I want you to write these. Write these in your book. Write them in. What's this one?
Greater than.
Greater than. Oh, that's very messy. Let's write that a bit later. And of course, we all know what the last one is. It's equal to. So we need to make sure we remember those. Now, sometimes a few of us are getting a little confused with the less thans and greater thans. You need to make sure, how do we remember which way they went? Remember we talked about it being like a crocodile's mouth, and it was open towards the larger number because crocodiles always want to eat the biggest thing. Actually, that's not true, but anyway. Let's just pretend.
They totally do.
Okay. So, if I had something really obvious, like the numbers are 2 sevenths and 5 sevenths, this one's a nice easy one to start off with. Which one should I put in?
10.
So we actually put a less than in because this one is bigger, okay? Because 5 sevenths, clearly I have more of them, and so that would be larger. Yes, we're going to write a couple of examples down. We're going to write these examples down. What if I had something like 1/6 and 1/7? How do we know what is bigger? Is a 6th or a 7th bigger?
6.
So it's a bit of an argument here. Quiet.
6.
Quiet. I'm going to explain it when you're quiet. Okay. So we all agree that 7 is a bigger number, isn't it? 7 is bigger than 6. Shh, hands down, I'm going to explain it. So 7 is a bigger number than 6. But a 7th means, so if I got a cake and I cut it into 7 pieces, whereas a 6th means I got a cake and I cut it into 6 pieces. So if there are more pieces, the pieces would be smaller, wouldn't they? So if there are 7 pieces, so they are smaller. So 1/7 is smaller than. So the 1/6 is the bigger number.
Did I get it right?
Pardon?
Did I get it right?
Did you say 6? Yes. Then you got it right. Well done.
Okay.
Okay. Shh. So if the numbers on the bottom are the same, we can easily tell which one's bigger because the top number is bigger. If the numbers on the bottom are different, we're going to have to think very carefully. It gets even trickier if I don't have just one. We are going to have to use our idea of equivalent fractions to help us in the next example. So example number 3, I'm going on the next page. Oops. I'm going to have 2/3 and 3/4. Now we know that thirds must be bigger than quarters. So if it was 1/3 and 1/4, well, if it was only 3 pieces, it'd have to be bigger pieces. But it's not obvious whether 2/3 or 3/4 is bigger. So what we're going to do is going to find an equivalent fraction to compare them. To do that, I want you to tell me what is the lowest common multiple of 3 and 4. We've been practicing this. Not the factor, lowest common multiple. So the multiples of 3 are what? 3, 6, 9, 12, 15. What are the multiples of 4? 4, 8, 12, 16. Which is the lowest one? 12. So, could we write these as 12ths instead? Who remembers with equivalent fractions, what did I have to do? If I timed 3 by 12, 3 to get to 12, I timed it by 4. I was only allowed to do that if I also did what?
To the top.
I also did the top, that's right. I want you to move one chair round, please. Yes, because you're talking. Stop talking and move now, quickly and quietly. So if I have times the bottom by 4, it would change the fraction unless I also times the top by 4. Because remember, 4 on 4 was the same as 1. And we're allowed to change things by 1. So what's the top going to be? 8.
Miss?
Yes.
Well, wait, it was 10, 10, 10, 10. Will that be equal?
Yes, so we'd have to look at the top number to then compare them. This one over here, what did I multiply 4 by to get 12?
You've got to multiply the root.
And if I times the bottom by 3, I have to do it to the top or it's not equivalent anymore. And 3 times 3 is?
9.
Now it's really obvious which one is the bigger fraction, isn't it? Because 9 twelfths is clearly bigger than 8 twelfths. So this one will be bigger, so I can go back up here and I know that 3/4 is bigger than 2/3.
I thought 2/3, because that might be a half.
It's both of them are bigger than a half.
Ah,
Okay.
nice.
So, shh, quiet. So we've looked at 3 ideas. The first idea was that if the denominators are the same, the biggest one is the biggest numerator. If the denominators are different, the bigger the number, the smaller the pieces. And we've looked at if they're different and different tops. Chad, now, quickly, back to your right spot. If they are different, we're going to have to use our equivalent fractions. So that's the hardest one. Now, we also have to watch out for mixed numbers and negatives. They can stick anything in there for comparing them. So, for example, if I had negative 3/4 and then 1/4, which one is bigger now?
It's the first one.
No, this one has a negative. So you're right, 3/4 is bigger than 1/4, but because it's a negative,
Oh, so it's smaller, but the
this
1 out
one
of 4 is better.
yeah.
Sorry.
So that's a bit trickier. It doesn't matter that 3/4 itself we know is a bigger fraction, but because it's negative, that is going to be less than. Remember on our number line, it would be off to the left. Okay, your turn to try a couple. You want to stop the video now? And we're going to try something else.